to answer any questions. And the other thing is, Dawn, can you please just give me a 10-minute warning, or 15 actually? So about 15 minutes before the end of the webinar, that would be great.
Okay.
So we'll get started, we'll get underway. So if everyone can just mute themselves and hide their video while I do the presentation, and then we'll come back and you can share your video at the end. Thank you very much. Right, so I'll share my screen now. Just bear with me while I, oops. Won't show. Okay. All right, so we're talking about what is biochar. I've already introduced myself. There is my contact details there. And you saw on the background slide before, there was a scanning thing for anyone that's interested in actually purchasing biochar as well. Okay, so we'll go through. So the topics that we're going to cover through this webinar is biochar as waste to energy via pyrolysis, biochar and agriculture, feedstocks, technology, on-farm technology, larger in-field pyrolysis, forest pyrolyzers, continuous pyrolyzer case studies, biochar producers and where to buy, and the carbon economy. So I just wanted to really cover off on what is biochar, because often we talk about biochar as the product itself, but the industry is all about the process of biochar and production of biochar. When biochar is produced, it's made by pyrolysis. So in the absence of oxygen under high temperatures, up to 800 degrees Celsius. And in the process of pyrolyzing biochar, different to carbonisation, or different to combustion. Combustion uses oxygen, pyrolysis is the absence of oxygen. That process is what makes the biochar special and makes it activated and has anions and cations and electrodes that can be donated and stored. When biochar is processed in the absence of oxygen under high temperature, everything that is burnt off can be captured as energy in the form of heat energy, biodiesel, syngas, and can even make things like hydrogen and wood vinegar. So everything else that is captured as an energy, if you like, and everything else that remains is biochar, which, depending on the temperature and the feedstock and the technology, ranges from 50 to 80% carbon. And we will talk more about the range of feedstocks shortly. Some of the issues that we encounter through ANZBIG and through sale of biochar is because of the range of technologies, temperatures and feedstocks. The way that I work around that is, if there's a takeoff or someone that wants to utilise biochar, the key message there is that if you're wanting a big takeoff agreement for biochar, that a fit for purpose biochar can be made for your purposes, but the whole business case needs to be developed, carefully choosing the technology and feedstock. Okay, so biochar for our industry means really no more waste. It's estimated that 50 to 100 million metric tonnes per year of biomass residues go into landfill or are burned every year in Australia. This could produce 10 to 30 million metric tonnes per year of biochar in Australia, and it has the economic value of $7.5 to $15 billion per year. It also has a carbon drawdown benefit, which we'll talk about shortly. So let's talk about biochar and agriculture first. So biochar is redox active, as I mentioned. That process of pyrolysing and the absence of oxygen under high temperatures means that it generates these electrons that are there that can be there to store and donate.
Can I interrupt you, Melissa?
Yes.
The screen is not moving at my end. I'm not sure if others are seeing it moving, but I didn't see it move. I'm still seeing the front page.
Okay.
Yeah, I'm also seeing the front page just.
Okay. I'll stop sharing and I will, my apologies.
Try again.
I will start again and see. I'll just flick through the slides. Don't know why that happened, so I'll just. Okay, so are you seeing slides flick now?
Yes, yes,
Yes,
yes,
that's
we are.
great.
Okay, apologies. So this is the first slide. This is the slide of the waste to energy process. So I'll just quickly recap. So we've got the pyrolysis, everything that's burnt off is captured as energy, and everything that remains is 50 to 80% carbon. And then I talked about biochar being no more waste and the waste available in Australia to make biochar. And now we're going to biochar and agriculture. So as I mentioned, biochar is redox active, and it's a substance, once it's made in that high temperature in the absence of oxygen, it has a high surface area that can store and donate electrons, and its surface area is a point for cation and anion exchange capacity. Now, 1 gram of biochar has a surface area of a house, so there's multiple surfaces on biochar that is this point for cation and anion exchange. So when it's put into the soil, for example, it means that the nutrients and minerals are awoken that also have a cation and anion, and it wakes up those nutrients and minerals. It's like a battery in the soil and makes them more available for the plant. But the same also occurs when it's fed through an animal, and it in turn makes those nutrients and minerals in the animal's diet more available. And it actually reduces feed intake. And there's multiple papers that have been published on the ability of biochar to reduce the feed intake while also increasing production. I've also published a paper on biochar feeding it through dairy, and we found 0.5 to 1.5 litres per head per day increase in milk yield by feeding biochar to dairy cows for a year. So that was a huge increase in production. So there's many papers that quote that in high diets, energetic diets, such as dairy, as well as feedlots and the like, it should contain electron-mediating substances. Now, biochar is that electron-mediating substance, and we really are working with nutritionists to help them better understand how biochar works in the rumen of an animal, because it's not a product that actually provides, it's not actually a feed. It is a substance that actually enhances the feed intake efficiency. And it's really important to distinguish the difference. The top 10 centimetres of soil sustains most life on Earth. 1 gram of biochar, as I said, has the surface area of a house. Its pores also provide a stimulant for microbes. It's a microbial powerhouse or fuel cell, and it is up to 80% carbon. So in cereals, where it's very difficult to increase soil carbon because you need year-round photosynthesis, biochar is carbon and is a way of increasing that soil carbon and production. So to me, the highest order use of biochar is agriculture through an animal. If you feed it through an animal first, you can improve things like the milk yield, animal production, conception rates, and the feed conversion. But the biochar is not digested, and it ends up in the dung. And we found in the paper that I've published that the dung is much more highly concentrated in nitrogen, phosphorus, potassium. And so in the presence of dung beetles, the dung beetles or earthworms or other, even plant roots, will take that activated manure into the root zone of the soil, and it's a fertilizer that can be spread through an animal. This will then increase the soil health, soil carbon, productivity, soil water holding capacity, and drought resilience. Or you can directly apply it to the soil to do the same, or you can add it to fertilizers to increase their longevity in the soil or composts. In a week's time, there is a biochar and nitrous oxide webinar that ANZBIG are running to talk about how biochar reduces the nitrous oxide emissions from fertilisers, from synthetic fertilisers, one of the biggest contributors to carbon and nitrous oxide in the atmosphere. And there will be a link that I'll share on that later. There's a report on the value of biochar and wood vinegar also on the ANZBIG website, and that looked at a whole range of uses of biochar, from feeding to animals through beef cattle right through to horticulture. Now up the top there, this paper really talks about the value of the increase in production by 1 tonne of biochar. So in avocados, for example, for every 1 tonne of biochar, there was $100 increase in productivity. But when we get down to horticulture, for every 1 tonne of biochar, consistently there was an excess of $20,000 increase in production. And that is because biochar in horticulture, especially those annual horticultural crops, you can get biochar right into the root zone, and that soil water holding capacity and the ability of that biochar to rapidly change the soil characteristics to improve production. And that's been reported time and time again. And if we looked at the dairy cow project for 1 tonne of biochar, we got nearly $5,000 increase, and that was just from the milk yield. It doesn't even talk about the ongoing increased production in pasture. Now, I just wanted to touch on what does 1% increase in soil carbon provide, because bearing in mind that biochar is carbon and you can rapidly increase your soil carbon by applying biochar. So 1% increase in soil carbon can provide about 165 tonnes per hectare of carbon dioxide equivalents. And that has been published by the Soil Carbon Industry Group. It can give you 144,000 extra litres of water holding, or 10 to 30% increase per hectare in water holding. So that's huge, remembering that 1 gram of biochar has the surface area of a house and can absorb moisture. It can give you 10 to 42% increase in production, pending the biochar application rates. It can increase phosphorus availability in the soil by a factor of 4.6, and that is consistently repeated in most agricultural trials. It can reduce non-greenhouse gas emissions from the soil by 12 to 50%, can enhance biodiversity by basically we find an increase in especially under pasture system species that are germinating from those soils with biochar. And it can also provide that support for the microbial bridge, or it's a fuel cell, if you like, for microbes. So I'm just want to talk about biochar and agricultural production and the opportunity to potentially apply biochar through fertilisers. Australian government has an agricultural productivity target of 100 billion in farm gate output by 2030, and to achieve this we need to grow agricultural production by 3% per annum per year, and biochar can achieve this. For example, if all agricultural land in Australia is 427 million hectares, cropping, grazing and horticultural land is 63 million hectares. If we just look at those grazing and horticultural case studies that I showed before, where 1 tonne of biochar gave you $20,000 of increased production, increased benefit. So if biochar was applied at just 200 kilograms per hectare to 10% of cropping land, that's 1.2 million tonnes per annum of biochar applied. And then if pasture yields increased by, say, just 10% by the application of biochar, we can outweigh that. We can reach the agricultural productivity target in Australia by small amounts of biochar. And we'd use a similar analogy. If we applied biochar just to 10% of fertilisers, we'd achieve something similar. There's many non-soil industrial applications for biochar, and I'm conscious that we have some of those stakeholders on this webinar today. Metallurgical biochar is a very hot topic at the moment with the safeguard mechanism and the opportunity for the steel industry to replace coking coal with biochar and steel. ANZBIG have also run webinars and seminars on the use of biochar in roads and concrete. And because biochar has this lattice-like look to it, and you can see up in the top corner there, there's been discussions about how biochar in concrete reduces cracking and actually improves the concrete product. So there's lots of different studies going on in the use of biochar in many different industrial applications. And there is, through the ANZBIG roadmap, more biochar coming on the market. And I have a little opportunity for you to express some interest if you are interested in biochar. My aim is to match those companies wanting to use biochar up with those that are producing it. Okay, so there's a range of feedstocks, as I said. So let's talk about the feedstocks and how that changes the biochar quality. So it's really important I think it depends on, when you're establishing these business cases, the end use for biochar. Now, often projects are created without an end use in mind. And in fact, many projects at the moment are aiming to get a takeoff agreement for biochar production. But it's really important to keep in mind the feedstock and the quality of the biochar. So the feedstocks can range anywhere from softwoods to hardwoods. Hardwoods are much more porous than softwoods, so they create more water holding capacity. Biochar can be produced from sewage sludge. It's being produced from biosolids at the moment from Logan City Council and being trialled in Victoria by water bodies to make biochar from that. So high moisture content biochars require different technologies as well, but also how that biochar, how the feedstock, the type of feedstock, for example, nuts and wood and grape waste might be suitable for some technologies, but not others. Some technologies need to actually pelletize the material before it's made into biochar. So there's a whole range of feedstocks, but when it's biochar, we deem it as something that was once living. So it needs to be something that is not plastics or rubber tires. It needs to be something that was once plant-based or from waste like biosolids. So the temperature at which that biochar is processed also changes the biochar and the amount of anion and cation exchange, and there is an opportunity also with some technologies like SDA, for example, to make that biochar into activated carbon, which has a ready-made global market, and it sells at much more dollars per tonne. So I guess that the closing remarks from this slide is huge variability because of the feedstock, the technology, and the temperature in which the biochar is produced. And that really needs to be considered, and the end use in mind needs to be considered when a business case is being developed. So let's have a look at those ranges of technologies. So this slide shows you on the left-hand column there, we have stoves, batch kilns, fixed batch kilns, continuous and continuous fixed kilns. If you look at one of the columns going forward, is about the 7th column across, it tells you the range of temperatures in which those kilns can operate, and then they can all produce various quantities of biochar. And we'll look at some of those in detail. So there's outdoor stoves. Let's have a look at those now. And open kilns, which do produce smoke, but they are much more environmentally friendly method of eliminating on-farm residues, for example, than open pole burning, because you'll get at least 10 to 15 or 5 to 15% of the original feedstock as biochar. Yes, they still do produce carbon dioxide, but what they retain as biochar remains trapped as carbon. and doesn't release to the atmosphere. So there's a whole range of those available on the market, and those things can be suitable for on-farm use. The other option for on-farm use are these portable type retorts, which are more enclosed and produce more biochar and less carbon dioxide emissions. For example, this one that runs at 400 to 500 degrees Celsius per day and produces about 170 kilograms per day of biochar. You put about, up to 2 tonnes of biomass in. And then there's a whole range of different backyard welded together machines that operate. Some of these are commercially available, and there's a list of those on the ANZBIG website that I'll show shortly. Now we're getting into the large batch kilns. So this is one that the University of Adelaide have available. The parts are imported from China. You can see the cages down the bottom are filled up by up to half a tonne of biochar per cage. It goes into the machine, it's closed, and it runs for 4 hours, and then you pull out the biochar and load in another cage. So you can run that up to 4 times per day, and it produces about 1.5 tonnes per day of biochar. It's more easily to get EPA approval for units like that because they're all enclosed, but it does often require shedding space as well. Let's go into the larger infield forest pyrolyzers. So here's the first of the larger batch kilns. So Earth Systems are well advanced in their batch systems that they provide, and these are some of the earlier models. There's some much later models. They produce 1 to 5 tonnes per day of biochar. Processing again takes about 4 hours. There is wood vinegar available from these, which is a biostimulant for the soil. And then there's also potential heat energy that can be used for drying from some of these systems. These carbonisers are fit for purpose and are used by forestry often because you can go into the forest and process forestry residues, and they're mobile, but they can only be used at certain times of the year because they're open, and they only provide about 5% of the original feedstock as biochar. So there are other options, for example, of bringing that biochar to fixed kilns or continuous kilns, having them strategically placed throughout forestry locations. But obviously, there's a whole lot of elements to consider in those business cases. We're now going to just have a look at some of the continuous pyrolyzer case studies. So just starting with Logan City Council, and that used a gasification facility, and they are processing biosolids to bioenergy. It is an award-winning project and one that ANZBIG's quite proud of. They have carbon neutral operations already, the Logan City Council. Their input is biosolids, their output is gas, biochar and heat energy. Gasification will produce less biochar than pyrolysis, so it depends on what you want to produce. But Logan City Council wanted the use of the gas for their region, and they've been able to achieve carbon neutral operations, I believe, and more about that can be searched, and there's some great videos on that case study. Now, I just wanted to talk about Pyroco MK2, which is being piloted by the Greater Western Water facility at Melton in Victoria. They're piloting 5 different feedstocks, like biosolids and green organic waste or FOGO and canola straw to make biochar. And so they're piloting that, but a lot of water utilities are becoming more and more interested, particularly because of one of our champions, Craig Bagnall, who has a lot of associates in that area, and like Logan City Council, have used a problematic waste that costs money to process and now creating increased income and made their waste into a resource. Frontier Impact Group, this is a project in Narrogin in Western Australia have designed a renewable energy project. I believe it's now gained over $4 million of funds and has the go-ahead from Western Australian state government. It is producing renewable diesel and 8,000 tonnes of biochar per annum from 6 million litres of wood vinegar, and it's sourcing the biomass from agricultural residues, including oil mallee, crops and forest residues. And it's another fantastic case study. This one is Rainbow Biochar, and this is in South Australia, in Tantanoola, and I was just close by on the weekend actually. It makes biochar from local feedstocks, and especially being in the forestry region, there's some waste timber as well. It produces clean syngas by injecting air into the pyrolysis gases. It uses the energy to replace LPG and electricity while producing biochar, and they currently sell carbon credits through the Puro website and sell biochar. And it's another great case study, and Peter Burgess was on ANZBIG and really has paved the way for projects like this. Prototype 2 and 3 are now being produced by Rainbow Biochar, and SDA Engineering designed this original model and also have their own prototype 2 and 3. So speaking of SDA Engineering, they have a range of projects also on the go. They have a CM3 machine which pays for itself within a year, typically due to the energy replacement. So the CM3 machine processes about 600 kilograms per hour of feedstock and provides 600 kilowatts per energy of heat that can be used to replace natural gas or syngas. And if there's no use for the heat energy, then it can be used to convert to electricity energy. And SDA Engineering have a background in green energy production. They also have the CM4 unit, that is a prototype that basically will produce 1,000 to 1,500 kilowatt energy per hour and process 1,000 to 1,500 kilograms per hour of feedstock. This particular technology has the option also to make activated carbon, which is a very high output and high valued product. And they have a long track record of green energy and pyrolysis system production. As I said, they're now for the complete package. And if you look at that little barcode in the bottom left-hand corner, if you want to scan that at any time, not just for SDA, but there are other, SDA have a range of projects on the go, but there's other projects that I'm hoping to support those that are in need of small to large quantities of biochar and match them up with the producers. So if you want to submit an expression of interest, just use that barcode. I just wanted to also talk about CETA's technology, which combines thermal and chemical looping principles to produce optimal pyrolysis and gasification outcomes. So this is the only type of technology in Australia at the moment that uses both pyrolysis and gasification together. And they've got a prototype, which I know there's going to be some exciting announcements on that shortly, and you can go to the CETA Group website. This is one of the higher feedstock processing systems. So once their first system gets underway and is available, they'll be able to process 5 tonnes per hour of feedstock through the use of recirculating solid state heat media and oxygen. And the process results in a high quality biochar concurrent with clean undiluted syngas. And this technology also has the option of producing the likes of hydrogen. So it's a really exciting technology and will be a game changer when it's shortly going to be available through CETA. I just want to talk about Kangaroo Island. So on Kangaroo Island at the moment, there is a project that is running through Kailand, and on Kangaroo Island, there's 6 million tonnes of timber, which could theoretically produce 1.5 million tonnes of biochar and 4.04 million tonnes of emission avoidance carbon credits. So Kailand are working with their own timber, about 4.5 million tonnes of that, but there's still 1.5 million tonnes of remaining timber that's owned by farmers. And my company, Carbon Drawdown Projects, is working on a solution for those farmers as well to process that feedstock that you can see there in the left-hand corner into biochar. Okay, so now let's have a look at the range of technology providers. These are members of ANZBIG. There's obviously other technology providers that are available, but these are the range of technology providers that are currently available through ANZBIG. So I've talked about some of these being Earth Systems and Biochar, which was used by Logan City Council, Rainbow Beta, Cedar Group, and then STA Engineering, who I represent here in South Australia. And I know that there's Apple Industry Online, and it depends on the amount of feedstock you've got to be able to fit really the technology, look at the right technology to process your feedstock, and then look at the resulting energies or outputs as well that might be available. So, for example, SEA Engineering, primarily its value looks for those that have a heat energy requirement, and the heat energy requirement replacement will pay for the system within a year, and then the biochar and the carbon credit sales are a bonus. Waste Ecology is another one that has a high output and high yielding output biochar, and that is, they claim 60% throughput, but they don't have any heat energy. So there's different fit for purpose. So that really, I just wanted to kind of drum that into those that are looking at projects, because, being able to put the business case together, for example, STA Engineering projects will make much more economic sense if there's a direct heat use. Okay, so nearly finished actually. I've probably gotten through this quicker than I thought, which opens up opportunities for question. I just wanted to finish off on the carbon economy. Hang on, forgot there, sorry. Looking at biochar producers now and where to buy first, and then the carbon economy. So now we talked about the different technology providers. Here are the different biochar producers. So AGSPAN, these are all the current members of biochar that are of ANZBIG that are selling biochar. So AGSPAN, Byron Biochar, Carbon Powered Mineral Technology. They also make products for animal feed and for fertilizers. Envirochar, FarmChar, Frontier Impact Group, Greenman Char, which is from Earth Systems, Conchi Oil, Soft Agriculture provide some really great animal and feed and soil products. Simcoa and SEA Engineering now, with their number of projects on the go, are triaging those into the opportunity for larger offtake agreements. And again, there's that scanning opportunity up in the top corner, or you can use that SurveyMonkey link there as well. Okay, so let's talk about the carbon economy and carbon removal. The International Panel on Climate Change, which has over 2,000 scientists, has 6 key technologies that it has recognised to draw down carbon. And we need to draw down 6.6 gigatons of carbon dioxide equivalents per year. And the biochar industry is saying that they can draw down globally 1.8 gigatons per year. So that could be up to a third. There's papers published talking about the biochar carbon capture. So that's really important. When biochar is produced, the feedstock no longer emits carbon dioxide equivalents. So all feedstocks, something that was once living, as they sit there over a period of time, they will emit carbon dioxide. If they're burnt, they'll do that much more rapidly. As soon as it's turned to biochar, that carbon remains within the atmosphere, and it becomes a very, very valuable product. But if that biochar is then also used in the soil, there's papers to show that the combination of making biochar and using biochar in the soil can sequester up to a third of global carbon. So because of the carbon economy, that has huge value just from various carbon credits. So if we look at the middle top little circle there, that's about biochar and how biochar can trap carbon. The other biochar carbon drawdown options are agro-reforestation, for example, trees, enhanced weathering by spreading basalt across large areas of land. It will absorb carbon. We've got direct air capture and a range of others. Okay, so now I just want to talk about cyclic carbon. Biochar really is about recycling carbon from waste, but something that was once living. Currently, Australia uses 2.6 times the resources it can recreate in any one year. And globally, 50% of soil carbon has been released to the atmosphere. And when we've historically gone from something like 8% soil carbon in Australia down to less than 1%. And as I showed earlier, for every 1% you increase your soil carbon, you can increase your water holding capacity and production by around 10 to 30%. Biochar captures and stores carbon. Biochar carbon capture alone can reduce Australia's emissions by 10 to 15%, and if it's applied to the soil, by a further 10 to 15%. I guess that the take home from this slide is that biochar is recycled carbon. And so from a climate emergency perspective, we can no longer afford to, from a climate perspective alone, keep burning those wastes. They are a resource and they can be turned back into carbon and put back in the soil. And we really desperately need to recycle that carbon for food security, and getting that carbon back in the soil would increase productivity, production, and in the driest state, in the driest continent that I come from here in South Australia, water use efficiency is extraordinarily important. As I said, there is 170 types of carbon credit options, and if you go around that little wheel there, a lot of biochar can be applied to many of those carbon credit options, and there are carbon brokers that are being very creative about how biochar is used. In Australia, there's the soil carbon credit through the Australian Carbon Credit Unit, but there's also soil carbon credits that are being traded globally. And remembering, when biochar is produced, it can also produce renewable energy. So depending on the platform that you trade the biochar on, there's also renewable energy options, or there's options to trade biochar carbon credits and also look for renewable energy carbon credits. It's huge, the carbon economy and the options for biochar carbon credits. While most mitigation activities focus on reducing greenhouse gas emissions, carbon drawdown aims to reduce concentrations already in the atmosphere or about to be released into the atmosphere. So that's the important difference of biochar. It is traded on voluntary markets through dedicated marketplaces, trading globally to private companies such as multinationals as Microsoft. Carbon dioxide removal credits typically trade internationally at 3 to 5 times higher than the Australian Carbon Credit Unit, and carbon removal certificates are what is funding biochar making projects. There is also additional credits when biochar is applied to the soil, as I said, and a whole range of other carbon credit options. You just got to look around. I just wanted to touch on one of the platforms, Puro, that are trading carbon dioxide removal certificates, and the 3 that have been approved to do that in Australia at the moment, but you can go to the Puro website to look at a whole range of other biochar projects and the certificates. So I talked about Rainbow Bee Eater, which is one of the case studies, and that's selling its biochar carbon removal certificates for €248 per tonne of carbon dioxide equivalent. And then there's Pyrocow, which is associated with Logan City Water, and that's selling 155 carbon dioxide, €155 per carbon dioxide equivalent. And then the Jeffreys project in South Australia as well. So we've got 2 of those in South Australia, also getting about €150 per carbon dioxide equivalent. And you can go on there. There's some projects that are producing that are selling their carbon dioxide removal certificates for up to €500 per tonne. And the life cycle assessment is very important for any project. So in order to obtain these prices, a whole life cycle assessment of the production of biochar from when it was waste right through to the end is done through a life cycle assessment, including transport, emissions from the system, and then you get an overall net positive in carbon dioxide removal. And so that's very, very important. It's a newly emerging space. There's only a handful of providers in Australia at the moment that can do that life cycle assessment. It's an opportunity for companies to get their head around. There's life cycle assessment opportunities and workshops all the time from life cycle assessment in Australia, if you Google that as well, to familiarise yourself with the process. There are companies that will take 25% of your carbon dioxide certificates in value to help set your life cycle assessment and process up. But I really encourage those companies that are looking at doing this to get their head around it themselves, because you can actually potentially give away a lot of your revenue because you don't understand the space. So it's very important to understand that space and how it all works. So to summarise, biochar revenue or biochar project revenue opportunities include the carbon credit sale of biochar, potential sale of activated carbon, sale of syngas, biodiesel, or hydrogen, sale of wood vinegar, sale or replacement of heat energy as renewable energy. The fact that you're not also paying to remove or reduce waste. Potentially, if that biochar is used in the soil, you can get Soil Australian carbon credit units, or you can get carbon soil credits through an offshore platform as well, and increase production. So the whole, I guess, value proposition of biochar, it ain't just biochar. And I hope that you've understood that as a result of this webinar. The Australian-New Zealand Biochar Industry Group has produced a roadmap, and there is the board and the advisory board members that are all involved in various projects, and ANZBIG has now, I think, around nearly 200 members. Don might correct me, and 20 of those are doing multi-million-dollar projects, with a whole range of those aiming to scale up production. ANZBIG wants to get the industry to a $1 to $5 billion industry by 2030. We have a whole range of initiatives. And now, if you're not a member of ANZBIG, we encourage you to become a member of ANZBIG. But also, we have an advisory group meeting next week that is also talking about leading some of these initiatives. We've combined these 10 initiatives into 5 different working groups that are aiming to help support the scale up of the industry. And if you want to know more, please get in touch with either Don or myself, or go to the ANZBIG website. It's really exciting to be part of this board that is looking at such an exciting industry that can do so much for carbon drawdown, but also increased production in agriculture, and also the reduction of emissions from a range of industrial industries like steel and concrete and roads. If you want to get on board as well, we'd like you to support the 10 key initiatives and get in touch about how you can support those. We're also looking for options to fund to scale up. You can look at the roadmap, and you can also pledge, make a biochar pledge. I think I just wanted to also talk about, and I think somewhere I thought in here I had if you go to the roadmap, or I think this is the barcode for the Australian-New Zealand Biochar Industry Group website, but just scan it. Remember the nitrous oxide reduction emission webinar that's coming up, but also there's a whole range of other exciting things that ANZBIG are doing, including the New South Wales Forum that's coming up at the middle to end of November. If you're in New South Wales, you're welcome to attend. South Australia, each of the states are also having their own roadmap and biochar conferences within the next 3 or 4 months. South Australia's is in February of next year. So if you would like to attend, please let me know and I'll add you to the database. And I'm sure if you're on here already, I will be in touch. So that's it from me. Thank you so much. I will stop there and we'll look at what questions we've got. So please, by all means, we've only got a handful of us online today. So please, by all means, just share your video and raise your hand. I'll start with looking in the chat at any questions. And before I do that, Don, did you want to add any points of clarification or just say anything in relation to what I've just presented?
So I don't think I can add anything to that. I thought it was excellent. So I think you have pretty much, you've pretty much covered it all. Yeah. In the roadmap, yeah, there is some wonderful infographics on all of the different markets for biochar and also for biocarbon. So if the the material is used in an oxidative or metallurgic process, we actually classify it as a biocarbon or metallurgic coal, and that is for emissions reduction. That is the big push by the IPCC, but also the Australian net zero targets. But the biochar is the carbon removal side of things. So industries, heavy polluting industries, are aiming to do their best by replacing coal, oil and gas in their processes, and then they can get to net zero by removing the rest and using biochar in soil and also non-soil applications. So those infographics are in the roadmap on all the different markets that you can use the biochar and the biocarbons in. So, yeah. Thank you, Don, and thank you for all of the fantastic work that you have done for the industry. You really are an unsung hero, and yeah, I highly respect Don and what he does. So now, Roger, you've said, can we share the presentation with our biochar cluster group and land care board? Yes, you can. It will be available after, because I've got another webinar next week on the 31st of October at 5:30 p.m. So I would like anyone that can to come online and register for that. That just helps the biochar industry. And some of that money goes back through to ANZBIG and my company as well. And then after that, the webinar will be available for free on my website. And I think we'll also put it onto the ANZBIG, and we'll share those links with you when that's available. Cherry, you've said, I understand that biochar is generated from feedstock that was once living. Is there any scope to look at maybe a char made from municipal solid waste, which would be a mix of materials? Yes, that is happening, and I believe Logan City Council have done that, and also the other water group that I mentioned in Victoria, and happy to hook you up with those, Cherry. Just please send me an email offline. So that's where I think we need to engage more with local councils about the opportunities of biochar from biosolids and oh, sorry, I've mixed it up. Municipal solid waste, not biosolids. There is, and that can be pyrolyzed, but it ends up, and often plastics and PCAS is burnt off in the technology. But you've got to be very careful about how you use that biochar. And I think, that again is a fit for purpose trial. So what often happens is that some of those materials can be provided to someone, for example, like SDA Technology or any of the others. A trial is done where the municipal solids are put through a pyrolysis system and the biochar is tested and then looked at for what it can be utilised for. So potentially I would suggest you'd get some funding or do like a feasibility and have a look at the range of feedstocks that might be able to process that solid waste and then find a use for it. And certainly I know online we have
roads industry here, and we have the steel industry engaging, and both of those have really already requirements for that biochar quality. So we need to find a use for that, and I guess that's the clincher. How far away is Australian methodology for biomass to bioenergy ACCUs, etc.? Actually, Don went to the ACCUs webinar only a week or so ago and may be able to talk about that. And certainly ANZBIG is advocating in that space. Did you want to attempt to answer that question, Don?
Yes. So we had a ACCU review, the Chubb review last year, and now they're implementing the action plan for the review or update of the ACCU scheme, and it was positive for biochar in that they will consider, expansion of carbon of new methodologies like biochar, and this is through a proponent-led process. So that means effectively an industry-led process whereby we will carry out stakeholder engagement and do the work to then be considered by the ACCU scheme. It doesn't guarantee that we'll get it in the scheme, but there's certain signals that would indicate it's highly likely that we would get it in if we get to certain stages. It's been estimated that per methodology, so we're in our roadmap, we're looking at 2 methodologies. One is for soil and non-soil applications of biochar, and the other one is biochar for animal feed. So that's involving emissions reduction. And as Melissa mentioned, the method of dung beetles burying that biochar is one of the most cost-effective ways of building soil carbon. So it's estimated that it could be in the vicinity of something like $1 million per methodology, to get it up. So we have some of the largest companies now contacting ANZBIG directly. We had a company that has agriculture. They want to purchase 250,000 hectares of land in Australia for grain production. We have the second largest forestry and paper company, OG, now as a member of ANZBIG, and they want to make biochar from their forestry residues, but also their paper mills, and they want to rehabilitate mining sites, using biochar and growing forests on those old mining sites. So that's, anyway, they have offered they have asked, what are our efforts in getting a biochar methodology in the ACCU scheme, and they've potentially offered to help us, because they all want to generate ACCUs. The carbon markets that Melissa mentioned is the voluntary market, which is getting a very high price at the moment for the biochar carbon removal credits.
Yeah,
but the compliance market, the ACCU, is the big market. Yeah,
that's right. And so I think that's the thing. If you've got state government related projects, is who gets carbon credits. But certainly ANZBIG have a range of buyers lining up also for the carbon credits and engaging with ANZBIG. So I'll just ask you all to share your videos. If you've got any other questions, please just put your hand up or say now. Otherwise, so any other further questions or comments or anything at all? We've got a small group here. You're welcome to chime in. We've got a couple of minutes left. No? Well, thank you so much for coming today. And yes, we'll let you know when we share the video. And probably the next one I'll share, because the third one's always the best. You iron out all the glitches. So thank you for engaging with us today. You know where to get more information, and I hope it was useful for you and your business. And we'll look forward to, if you're not already engaging with ANZBIG, hearing from you. So that's all for now. And thank you, Don, for supporting today. And we'll see you all soon. Bye.